Okay, so I had to think a bit there because this is actually a slightly trickier problem than I thought it was. That is to say, you can't use the sine rule initially. You're going to have to use the sine rule in the end, but you can't use the sine rule initially because there's just not enough information. You've got two unknowns. This is unknown, this is unknown, and this is known. So you haven't got enough information. So we're going to have to add information. And the way we're going to do that is we're going to use the cosine rule. What I'm going to do is I'm going to draw out this triangle here. And in this one, we've got 120, that's 6.4, and this is 3.8. And what I can do is I can work out this angle using the cosine rule, because here I've got three sides and one angle. So let me just quickly work that out and I'll explain why I'm doing that in a minute. So the cosine rule is given at the front. A squared equals b squared plus c squared minus 2bc cos A. And the crucial bit is that you have the two lonely sides. Got these. We've got this is like a lonely angle. That's a lonely side. Okay, which is sides are always lowercase, angles higher case, and then you've got this thing here. What I call the sandwichy sides. We've got the two sides that work together in the formula here, 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 and here. They're buddies, they work together in the formula. So even if you don't have any letters at all, you should be able to match this up. So he's lonely at the front, so he's x squared equals 3.8 squared plus 6.4 squared minus 2 lots of 3.8, 6.4 cos 120. So if you can just see that, I'll pull that in a bit. Okay, so the buddies here, the buddies are working together in the formula, lonely side out the front, and the angle, the only angle is given away by the fact that's a capital letter. So let's just quickly put that into our calculator. So that gives me 3.8, so 3.8 squared plus 6.4 squared minus 2 lots of 3.8, 6.4 cos 120. Okay, and that gives me the answer 79.2. And what I'm going to do is just go x squared, just being a bit lazy here, and then I'm going to square root the answer. So x is equal to the root of the previous answer. Okay, and I'm going to write that down accurately, okay, because I only round right at the end of the thing. So it's accurate enough, I think. 8.9286. Okay, so why did I do that? Well, now I've got this length here as 8.9286. Okay, I can think of the sine rule again, and this time I could match the angle 120 with the side here, and I can say to myself that what is it, 6.4, the yellow one, 6.4 over sine theta is equal to 8.9286, 8.9286 over sine 120. Right? Now, the first problem is that the unknown is at the bottom of the fraction. And so it's perfectly fine. You know, if I've got 4 over 2 is equal to 20 over 10, okay, that's no problem, that's equal to 2, that's equal to 2, and if I flip it around, 2 over 4 is equal to 10 over 20, so there's no harm in me just flipping both these sides round, okay, and I get sine theta over 6.4 equals sine 120. Why did I do that? Well, because it's easier if the unknown is the numerator. Because now, okay, I've got two problems. I've got the sine surrounding the theta, and then I've got this division by 6.4. We need to unwrap from the outside. So the first thing I do is, in my mind, I'm going to multiply both sides by 6.4. I wouldn't write the fluffy clouds. Okay, that's what I'm just thinking in my mind. So sine theta is equal to sine 120 over 8.9286 times by 6.4. And then lastly, I need to get rid of this, and hopefully you can remember from your calculator, okay, the opposite of sine in something is sine to the minus 1. Okay, so it's going to be shift sine. So basically I'm going to go that theta is equal to shift sine, the answer to the previous question. So let's do that then. So let's just type in this bit here, sine 20 over 8.9286 9286 fail, oops, pardon, 8.9286 times 6.4 equals that, okay, and then I'm going to shift sign the answer, so shift sign, okay, the answer, and I'm going to get to that, so 38.372. Okay, and we want this to the nearest degree, so that's the degree, so that gives me theta equals 39 degrees, okay, which means that my bearing, okay, is 69 degrees, okay. Be careful, really easy mark to lose, and that is that all bearings must be given in 3 figures, okay, so 3 figures. Okay, so 069, a really easy mark to lose if you've got to put the 0 in there. Why did we add the 30? Okay, if you remember, we worked out that this was 30 degrees from parallel lines.